So now I will turn it to the engine of PEER, Dr. Amarnath Kasalanati.
Thank you, Khalid. Thank you all for coming around and staying around to celebrate our event. It is almost like our shake table test. We promised to do something at a certain time. Things slip a little bit, but we appreciate everyone's patience. People say life begins at 50. These are people on the right side of 50. So we certainly hope that is the case with our table. And I just wanted to talk a little bit about our future plans. Before future, maybe I'll focus a bit on what is happening now, what is presently happening on the shake table. We had a remarkable year, and this year we are doing about 12 research projects. These are researchers from UC Berkeley, LBNL, University of Nevada, Reno, UC San Diego, Caltech, SFSU, and so on. There you see the roof is open, and there is a wind turbine sticking about 25 feet past the roof. So wide range of tests were done. We had concrete columns, steel pipes, wind turbines, wood panels stuffed with straw. Professor Becker, thank you. And then aluminum panels stuffed with foam. So quite a range of research tests. And then we also had industry testing. We routinely do these seismic certification tests here, air handling units, generator sets, ceiling systems, power distribution, electrical buses, and switches, and so on. And we are actually doing one industry project that is over there with SOM. I say it's industry, but it is really like a research project because if you have more than 100 sensors, I would say it's a research project. And more importantly, if you stay past midnight or past 10 p.m. 3 days in a row, that's a research project. So it's and we appreciate SOM's support, their enthusiasm, and their patience, for with this testing of these new devices. So that is the present. So looking ahead, as you saw already, there was a major upgrade about 25 years ago. Went from 2D to 6 degree of freedom. So our hope is to do something more now. Lab is active, things are good. Why do we need an upgrade? Well, the table is 50 years old, and the displacement range and others are about 5 inches horizontal and 2 inches vertical. Okay, you may not be able to read all these numbers, and that's by design. I just want to. So our plan with the College of Engineering is to upgrade a wide range of things. Increase the displacement to about 12 inches, increase the velocity, increase the acceleration of force of the overall system, the weight capacity and everything, and convert the concrete tabletop to a steel. So all this to increase the range of earthquakes we can faithfully reproduce on the table, and that will help engineers do more research in a little different frequency range, or attract some work in nuclear field or other areas. So that is our broader goal. This is still the largest 6 degree of freedom shake table in the United States, and it will remain so for another week. So UC San Diego has a larger table, and our friends at San Diego decided to have their opening ceremony next week, so that we can still have the bragging right for the anniversary. So I thank Joel and Jose for doing that. So there are many good tables around the world. UNR has about 5 shake tables, and San Diego has a bigger table. Buffalo has a couple of them. But each one is good at doing something. Something has a better overturning, something has more displacement, something good for hybrid simulation, and so on. Some are larger. The Berkeley table is quite unique. It's at a sweet spot, I would say. I may be biased, but the 20 by 20 footprint and its capabilities, if we add that 5 inches going to 12 inches or so, we really take the central spot and be in the sweet spot of doing a lot of good research. So that's our main motivation for the upgrade. We are going to go from this pinwheel arrangement of a concrete table to a V-shape arrangement of a steel table. So that is our whole thing. So we have one little constraint, that is the lab is a recharge unit. So it has to generate enough revenue and pay for itself, staff, and all the things. So we cannot shut down the lab for 2 years and do this massive upgrade and go back. It has to be done a couple of months, a year or so, over a couple of years. Okay, so that and depending on the flow of funding from College of Engineering, and we also have other capabilities in PEER, as Khalid mentioned. We have a blast, fire, and other capabilities. So we are planning to upgrade those also at that time to increase the overall capabilities and some kind of an interdisciplinary research that can happen in the lab here. So the upgrade, it will go from there to there, and all the red pieces will disappear, and the black or gray ones will come. Okay, so that costs about $3-4 million and takes a bit of time. And so the first thing we are going to do is change it to a steel platen. And 20 by 20, it's hard to ship around anywhere, so it's going to come in 2 pieces. And we're going to bring it to the lab and weld that together. The design work of this has already been done by MTS and PEER team. By the way, MTS rep was in the audience, Sang Hoon, and he probably had a lot of candid feedback, which we will take back to Minneapolis, and I just missed to introduce him earlier. So, and then we're going to have some brackets underneath, because this steel table has to work with the 12 actuators we have now. So we're going to pop out the concrete table, drop in the steel table, and hope it works, and we continue the 8 months or so generating revenue for the year and so on. And then our next upgrade is we got these accumulators. So we are going to have a massive hydraulic upgrade and fix all the leaks and everything. And the pumps at the bottom, there is a nice story about that. They were military surplus that Professors Clough and Penzine got. They were designed to operate Titan silo equipment. They were designed to work only once and once properly. And 50 years plus, they have been working great. Okay, touch wood, but they are doing great. So, but we are going to do upgrade of hydraulics, and then we are going to procure 8 actuators, 4 vertical and 4 horizontal from MTS, and then we need to make some changes to our reaction block, because these actuators go at a different location, and they're going to anchor into the reaction block, and then when everything is ready, we're going to pop out that platen, weld some new pieces on it so it can accommodate the V actuators, and then put everything back and hope it all works. And when it works, we will have another function. This time we will do it on the table in the lab over there, and we'll have a color copy of this with you all in the audience. So that's our plan for the next 2-3 years. And before I finish, I want to say a word of gratitude to all shake table operators. We have heard about Dr. Dixon Ray. He was one of the first ones to do. I've not had any pleasure of working with Pat Quinn, but I was fortunate to work with the last 4. Okay, this particular one, this is 50 years, there are 6 people. We have had more presidents in 50 years than shake table operators. So it is a unique job. It requires a combination of structural dynamics, hydraulics, some kind of mechanical stuff, some electronics and electrical, plus signal processing. Some of these, they turn a wrench, wipe their hands, and then go do a quick MATLAB routine to process things. So you have to have the wide range of those skills. On top of that, the next most, or maybe the most important aspect is staying calm under pressure. Okay, that is absolutely needed for this job. Okay, because researchers, God bless them, but they want to push boundaries. Okay, 5-inch shake table, can we go to 4.99? How about 4.95 inches? But the table is non-linear. Depending on what's on the top, it may or may not move as you expect. So, and these people have done a great job of keeping the table running these 50 years. Now, if you privately reach them and talk, they will have a great story about how they brought down the table or when they had to hit emergency stop, although they may not admit it publicly. But I do thank them for their years of service in keeping the table running. Basically, we had great history, 50 years. We heard some wonderful presentations. There was a lot about isolation, and I was wondering, it's not me, right? I did not pick the speakers, but it ended up being a lot of isolation, and I really enjoyed that. But with the College of Engineering funding, the next 50 years look bright too. So, and we look forward to serving the next generation of researchers with the upgrades we plan to do in the next couple of years. So with that, I want to pass it on to Associate Dean Tariq Zodi. Tariq.